X to the m times x to the m. Okay, so in multiplying bases, you add the exponents. Next one, when you're multiplying, what's the difference between these? When you add the exponent, when you multiply, yes. What's the difference on the left-hand sides? Yes, something more. How many bases? 2, right? So there's 2 x's. How many bases? 1. So 2 bases you're adding, 1 base you're multiplying. What happens when you're dividing? Okay, negative exponent law. Okay, so that you all reviewed Friday. This one I snuck in from grade 10 because it's going to come up today. X to the 1/2, excellent. And if we put generic any kind of indice in there, it becomes 1 over n. Okay, so that's what we're going to use today. So what we're doing today is solving exponential equations. We have been solving equations since grade 9. Put your finger in the air. Very first equation you spent all of grade 9 solving, so we didn't want to overwhelm you, was linear. Show me linear. Awesome. Then grade 11, we're like, okay, you're ready for more. We're going to do quadratic in 3 units. Show me quadratic. Then we're like, okay, halfway through the year, you're ready for, some harder stuff. So we added in absolute value. We added in rational. You got lots of choices for rational. What are the choices? Volcano, speed bump, sad clown face, oblique asymptote. We also added in radical equations in grade 11. Then we came this year and we're like, hey, let's redo all those but do it graphically. So we did radical graphically, rational graphically, absolute value graphically. Then we're like, ooh, you're ready for sinusoidal. Show me those. Show me sinusoidal. Awesome. We did those graphically. We did them algebraically. Yesterday we did exponential graphically. Show me what it looked like. Perfect. So all we're adding now is, without graphing, do it algebraically. Where we're going in this unit is eventually to be able to solve exponential equations when you don't have a common base. So we're starting with the easiest type, which is common base, and what we're working up to in this unit when you don't have common base. That's what the whole unit is about. Then we have 1 unit left, then we're done, and we have an exam, then you're done. What's an exponential equation? So how do you recognize it? How do you know what it looks like? Okay, so take a look at the examples. For example, number 1, where's the variable? That's what makes it exponential. Example number 2, in the exponent. 3 and 4, in the exponent. That's what makes these exponential as opposed to anything else. I put them into 2 categories. First is when they have common base. Second is when they have radicals. Grab some paper, not mine, your own. When we're done this unit, we will have shown you every kind of equation you ever need to know. Makes me sad a little bit. We're almost done. Once you have the example copy, just pens down. You're just going to watch me do the first one, then I'll back up and I'll do it with you. I just want you to watch and not have to try to copy at the same time. So all I'm going to do is use what you know about exponents way back from grade 7. And what I'm going to do for this one is I'm going to take 4 out, and I'm going to put something else in its place. So I'm keeping the left-hand side exactly the same. I'm going to keep that exponent that's at the top. All I'm going to do is take 4 out, and I'm going to substitute 2 to the 2. So mathematically, is that okay? Yes. Why? Because 2 to the 2 is equal to 4. So I haven't changed the equation. I've just changed what it looks like. Then what I'm going to do on this hand side is use one of our exponent laws that says if you have one base and two exponents, what do we do with the exponents? We multiply. So I can make this 2 to the 4x. Okay. Then there's a rule in math that says if you have two bases that are equal, the exponents have to be equal. If you have two bases that are equal, the exponents have to be equal. So for example, 2 to the third has to equal 2 to the third. I can never say that 2 to the third equals 2 to the 5 or 2 to the 7. So if the bases are the same, I know the exponents are the same. So what I get to do is just cross out the bases. So I know whatever x plus 3 is, it has to be the same as 4x. How do I solve that? That's just a little linear equation. What am I going to do with the x's? Okay, probably I'm going to go to the right so I don't have to touch that 3. How do I get rid of the coefficient of 3? X equals 1. Could I check it? So you can check any single equation you've ever solved. How can you check an equation? Okay, so let's go back to the beginning and let's put 1 in. So simplifying the exponent first. So 2 to the 4. And on this side I have 4 to the, Chantal, put it away please. 2 to the 4. So 2 times 2 times 2 times 2. And 4 squared. There it is. Let's get a method first. This is the best part, is where you get to tell me the method and then I get to laugh. Do you think it's always going to be the right-hand side? Okay. You want to get a common base, so change all bases. To a common base. And usually that's going to mean the lowest base that you see, because you can't change 2 into a 4 easily. You can change 4 into a 2. So typically it's whatever's the lowest base that you see in the question. Okay, what did we do after we took out that 4 and put in 2 squared? Yep, so we simplified using exponent laws. You guys are getting better at this. Ooh, simplify using exponent laws. I'm just going to make a note. What that means is you're down to one base on each side. If you've got a couple bases hanging around, what that means is you're just not done simplifying. Okie dokie. I'll just show it to you again. So what did we do after we exponent laws? Drop the bases. We call that equate the exponents. Drop the base. I like that. All about that base. I'm ahead of you there. Okay, so step number 1. 4 is going to come out and become? And how did I know that? Because I looked at what's the lowest base in the question. What's lowest, 2 or 4? 2. So then I know I have to change 4 into 2, and the only way to do that is to make it 2 squared. Then the minute I have brackets, I know I need to simplify. How do we get rid of that brackets? Well, that's the multiplication exponent law that says you keep the base and multiply the exponents. So we did 2 times 2x, which gave us 4x. What's the trick to know when you're done simplifying? One base on each side. So there's 1, 2 on the left and 1, 2 on the right. Once you're done simplifying, we equate the exponents. And again, that's because if the bases are equal, the exponents have to be equal. So we drop the bases, equate the exponents. At this point, it's typically a linear equation. Sometimes you'll get quadratic, but it's typically linear. Solve it. We get down to be x equal to 1. No, it's just these are really easy ones to check on the exam. They're not that like sinusoidal where there's a lot of work. So on the exam, if you want to know for sure if that's the right answer, throw it into the question, check. Okay, so if you want to copy the checking, great. If you don't, that's fine. You just solved your first exponential equation. It's kind of exciting. Today or this unit? Not harder, different. Today it's going to get harder. It always gets harder after the first one. Okay, so here's a little tricky one, because you have 4 and you have 8, and I said usually you look at the lowest exponent, so that, or lowest base, which would be 4. The problem is, can you change 8 into 4? You need to be careful. It's not 4 squared, because 4 squared is 16. So there's no way to change an 8 into a 4. What that means is there's an even lower base we can turn them both into. So 4 and 8 are linked to 2. So we're going to change both the bases on this time. So I'm going to keep that x as the exponent. I'm going to keep the x plus 1 as an exponent. All I'm doing is what's called substituting equivalent expressions. 4 can come out. 4 is equal to 2 to the 2. 8 can come out. It's equal to 2 to the 3. Okay, so sometimes when you look right away, you're like, but I can't turn them. Well, that just means there's a lower number. And you're typically going to see this with 4s, 8s, 16s, because 2 is the lowest base. Oh, thank you. Better? Okay. Brackets on both sides tell me I need to simplify both sides. This exponent law is the most common that says if there's one base and 2 exponents, we multiply. So keep the base of 2, 2 times x. This one, what I like to do is when there's a binomial, I like to bracket it, because when we multiply, that 3 has to apply to everything. And sometimes when your brain sees brackets, it remembers that better. So when I multiply the exponents, I have 3 times x, and then 3 times minus 1. Okay, so again, sometimes those brackets just helps your brain to understand we have to distribute. How do we know when we're done simplifying? 1 base on each side. Do I have 1 base on the left and 1 base on the right? If the answer is no, it just tells you you're not done simplifying. When I have 1 on the left and 1 on the right, what do I get to do? And equate the exponents. X is to the left or x is to the right? Ooh, to the right, okay. Check it. So left-hand side is 4 cubed, which is 64. This will be 8 to the 2, and 8 squared is 64. So really easy ones to check on the exam to know if you have the correct answer. Okay, let's go to the ones with radicals. They're no different. We just have to deal with the radicals separately. To the x is 4 square root of 2. And the only thing different is, first off, I'm just going to deal with this root of 2. And we know that's actually an exponent, so we're just going to use that radical exponent law that says this is really 2 to the half. Okay, so step number 1 is just convert the radicals to fractions. Okay, look at all your bases. I got a 2 and a 4 and a 2. What can I change that into to get common base? So which one do I want to change, and what do I want to change it into? I want to change the 4, so I'm going to keep the left as is. 4 is going to become 2 squared, and then I'm keeping that 2 to the half, not touching it yet. Okay, so the only thing that's different in the first step, I just had to deal with that radical and make it an exponent. Okay, minute I have brackets, I know that needs to simplify, so be careful of your laws here. How many bases do I have on the right-hand side? 2. So when there's 2 bases, what does that mean for the exponents? We add them. So left-hand side is going to become 2.5. So how do we add fractions? Common denominator, which would be 2. First numerator is going to become second numerator. Smush those together. How do we know when we're done simplifying? 1 base on each side. So is there 1 base on the left? 1 base on the right? What do we get to do? This is the best part. Oh, yay. Why? Why are we suddenly done? Because x is already simplified. Show me your thumbs. I'm getting this, I'm kind of getting this, I'm not getting this. Good. Yep, you can. Sorry, 4 and 1 over 2? Yeah, 2.5, not 4.5. Okay, look at this crazy one. So first thing we deal with is the roots. Don't worry about anything else. We just need to get those roots out of there and make them exponents. Okay, square root becomes 1/2. Okay, leaving everything else the same. The base stayed the same. That exponent on the outside stayed the same. What happens to a cube root? 1 over 3. Now we deal with the bases. So we look at 3, we look at 9. Which one can we convert? The 9. Everything else staying the same. 9's going to come out. 3 squared's going in its place. Do we need to simplify? How do we know? Brackets, okay? Again, when the exponent is a binomial, I like to bracket it to remind myself to distribute. If you don't need that, don't do that. 1 base means we're going to multiply. Okay, so 1/2 times x, 1/2 times -1. Right-hand side, 2 times 1/3 would be 2/3. Are we done simplifying? How do we know? 1 base on the left, 1 base on the right, and we get 2. There's something satisfying about canceling stuff. No, that's no puppy killing. That's legal. You like fractions or you don't like fractions? So what can you do if you don't want to work with the fractions? Multiply everything by? So what can we divide by 2 and divide by 3 at the exact same time? What's the smallest number divides by 2 and divides by 3? So we can multiply both sides by 6. Again, this is the option. If you'd rather work with the fractions, you can work with the fractions. This is just a choice to clear them. So 6 divided by 2 is 3x. 6 divided by 2, still 3. And on this side, 6 divided by 3, 2 times 2, 4. If your brain didn't like that and likes the fractions better, then go with it. You don't have to clear them. X equals? Questions?